So today we will be discussing about global warming and ozone depletion, which would be today's topic of our discussion. And these audio lectures are presented by A.S.S Science Foundation, Delhi. So first of all, we will see Wiens Displacement Law, which is a very important law where we see a relationship between the wavelength of the light emitted by any black body and the surface temperature of that black body. So according to Wiens Displacement Law, we see that wavelength of any black body is directly proportional to 1 by T, or inversely proportional to the temperature. Or we can write it as that lambda in micrometer is equal to 2897 divided by temperature in Kelvin. So here we can determine the temperature of any body in this universe if we know the wavelength emitted by that body or the energy associated with the body. So for example, let us suppose the average temperature of the earth is 15 degrees Celsius. So we can calculate the radiation emitted by the earth's surface, which would be lambda is equal to 2897 divided by temperature in Kelvin, and 15 degrees Celsius is equivalent to 288 Kelvin. So we come to a conclusion that wavelength emitted using this formula comes out to be 10.1 micrometer, which is also 10,000 nanometer, which falls under infrared radiation. So sometime they ask you this question, that in what range the Earth's surface emit the radiation. So it's nothing but 10.1 micrometer or 10,000 nanometer roughly, which falls under infrared radiation. So the terrestrial radiations emitted by the Earth's surface are 10.1 micrometer or 10,000 nanometer, and these radiations play a very important role in maintaining the temperature of Earth, or greenhouse effect. So generally we can say that Earth emits a radiation of 10.1 micrometer. Now in the very next diagram you can see that we have shown that the radiations which are coming from sun having high energy means low wavelength, so they are called as short wavelength radiation. Which are coming to the Earth's surface, and Earth's surface is also emitting some of the radiation, as we have seen these 10.1 micrometer, which are having lesser energy, means more wavelength, so we call them as long wavelength radiations, and they are trapped when they go back from Earth's surface by most of the greenhouse gases, major of the greenhouse gases, or we call them as radiatively active gases such as methane, CO2, H2O, CFC, which is chlorofluorocarbon, and N2O, which is nitrous oxide. So generally we know that Earth temperature would have been -20 if the greenhouse effect is not there. So in the absence of greenhouse gases, the Earth's temperature would have been -20 degrees Celsius. So natural greenhouse effect is generally done by CO2 and water molecules. So these are natural greenhouse gases, CO2 and water molecules. So they bring about some 15 degrees Celsius or 18 degrees Celsius of the Earth's temperature. So there is a net change of around 35 degrees Celsius. The temperature which was supposed to be -20 in the absence of greenhouse effect was come out to be the average temperature is 15 degrees Celsius for Earth's surface. That means change is 35 degrees Celsius. Then we have a relationship that whenever we have an extra 1 ppm of CO2 in the atmosphere, so why we are bothered whether it is 380 ppm or 390 ppm or even at 400 ppm? Because each ppm of CO2 add up some 2.12 gigaton of carbon to Earth's atmosphere. So that's why we are bothered. So it totally changes the carbon budget of Earth's atmosphere. And you must remember this relationship that 1 ppm of CO2 is equivalent to 2.12 gigaton of carbon. Most of the times they use this as a numerical question. So what do you mean by global warming? So global warming is nothing, it is excessive greenhouse effect, if you ask in general terms. So excessive greenhouse effect is global warming, and as we have seen from Wiens Displacement Law that lambda max in micrometer is equal to 2897 divided by temperature in Kelvin. So concentration of aerosol can also affect the global warming, means they have multiple ways to affect the radiation cover of the earth. So the concentration of the aerosol in the environment can also affect the global warming. The global warming can occur in 3 ways. First, if there is a change in solar radiations reaching up to the earth's surface, means if the solar budget or the insolation budget for the earth changes. Then if there is a change in fraction of solar radiation that is reflected, that is called albedo, right, or reflectance, and it increases with change in surface, the albedo changes. For example, in the case of Mount Pinatubo, so basically Mount Pinatubo was a volcano which released tons of sulfated aerosol in the environment, which is basically somewhat reflecting in nature, and it causes global cooling. And if we see the albedo, so fresh snow is having albedo around 1, which is 100% reflective in nature. Then we could have a change in the infrared radiation that is radiated back to space. So if there is a change in the radiation budget and this infrared radiation changes to some other wavelength due to some changes in environment, then also the global warming could happen. Now coming to the very important effect, which is greenhouse effect. So the natural greenhouse effect is essential for the maintenance of Earth's temperature, but remember one thing, the excessive greenhouse effect due to anthropogenic intervention in Earth's environment is referred to as global warming. So for general understanding, we can see greenhouse effect as like once the earth absorbs all radiation, the short wave radiations which are coming from sun, it must radiate on the average some amount of energy in order to maintain the energy balance. So if we are getting some energy from the sun, some energy must go back to maintain the energy balance. The earth does it by emitting infrared radiation, which we have discussed earlier, the 10.1 micrometer from Earth's surface. However, a considerable amount of infrared radiations, it does not escape into space. It will not go into space, but it is reabsorbed by the gases called greenhouse gas like H2O, methane, N2O, and water vapors in Earth's atmosphere. And then these greenhouse gases re-radiation back to the earth, and the warming effect caused by the absorption and re-radiating of infrared radiation by these greenhouse gases such as methane, N2O, water vapors, methane, N2O, water vapor, and CO2. So this effect of the warming effect, which is caused by absorption and re-radiating of infrared radiations by the greenhouse gases, which is CO2, methane, N2, and water vapor, is commonly called as greenhouse effect, which is denoted here as GHE, and greenhouse gases is denoted as GHG. However, the excessive increase in the greenhouse gases means anthropogenic activity may lead to excess of greenhouse gases. which in order leads to more of the greenhouse gases will retain the more infrared radiation, means more increase in temperature. So this excessive greenhouse effect due to anthropogenic emissions is referred to as global warming. We must keep in mind that natural greenhouse effect is necessary to maintain Earth's average temperature, which is somewhat around 15 to 20 degrees Celsius, but excessive greenhouse effect due to anthropogenic emissions of gases such as CO2, methane, N2O is referred to as global warming. Now we will be discussing the details of these greenhouse gases.